Hey guys, welcome to this session on Introduction to Programming and Algorithms. My name is Faizan and today we are going to talk about this session. So before I start, can you guys quickly confirm in the chat if I'm audible or not? Is the slide deck visible to you guys? Can you see the pointer over here? And if you can hear me properly, then give me a quick confirmation in the chat. I'm continuously monitoring your chat, so quickly write a yes or no. And in the meanwhile, let me give you a quick tour of how our academy looks like. Okay, so in our academy, you can see that when I typed in Great Learning Academy in my browser, the first link that is there, I clicked on it. Like I typed in Great Learning Academy, I clicked on this link, and this will redirect me to this page. Okay, and in this page, I can see many things. First is the career option. You can choose the career option if you are specifically looking for IT and software. We have different domains in the it: software development, front end, information security, Java developer, SQL developer. You can pick one of them. Okay, whatever suits you. Okay, I can see some yeses. Okay, great. Apart from it, we have career transformation programs with different universities. Like if I go into software development, you see there is an advanced certificate program in full stack development with IITR. Then there is another program where triple ITH MCA program, degree program is there, right? So you can see all of these things in this career transformation programs. Now if you're looking for something which is absolutely free, right, that is over here. So these are our popular courses, and if you're looking for something which is in IT and software, we have data structures, algorithms in Java, Java programming, Python fundamentals, right? And then you have CSS, HTML, blockchain is there, data structures in C is there, Android development is there, OOPS is there. So all of these courses are absolutely free. You can, once the session is over, you can check it out. And if you want to register yourself, just click on any course, right? Let's suppose this is the course, and you can enroll yourself right here. You see the button over here, enroll now. Then these are the things that will be covered in this program, in this course, like arrays, linked list, tag, queues, binary tree and binary search tree, heap is there, hashing is there, and graph is there. Okay, so all of these things are covered in this course. And plus, if you see the certificate, the completion certificate that you will be getting will look like something this. Okay, your name and then the Great Learning Academy. Okay, cool. The live session is little delayed. No, we have just started it, guys. We just started it. Okay, and these are all the courses which are free. And if you're looking for this, these are in English, right? If you're someone who is, for me, who is comfortable in Hindi, we have courses in Hindi as well. Okay, so you see over here we have courses in Hindi. These are all the courses which are in Hindi. Okay, plus if you want to check when the live session is there, some of you still have confusion, right? When the live session is started, what are the live sessions that are there, you can check it on this same page. Okay, so right now I'm taking this session on introduction to programming and algorithms, right, 4 to 5. Then tomorrow we have roadmap to learn JavaScript for beginners. Okay, so and you can view all the live sessions that are here, okay, that are going to be in this week and in the coming week. Okay, cool. So now let's get started with our session. So today we are going to talk about programming, introduction to programming, how you think of a solution and how you jot down those steps in the form of algorithm. Okay, great. Okay, great. Aditya, hello sir. Let's get started. Okay, so let's see the things that we are going to cover in this session. So we will first see how we should uh, s- look for things that are there in a given problem. Let's suppose there's a given problem. What are the things that you should look? What are the things that make your problem solving easy? Okay, how you can jot down those steps and then finally come to a point where you can write that algorithm. Okay, so first is the flowchart, right? Then there's a pseudocode, and then there's an algorithm. Okay, so these are the three main steps. Once these three steps are clear, then you can easily write down this in any programming language. It can be C, it can be Java, it can be Python, it can be JavaScript, any. Okay, so language independency, if you want to get a language independency, that you only know Java, you only know Python. So first learn these steps, these three steps. And before that, the most important step is the problem introduction. Okay, so yeah, Sonia, you can learn any language. Yeah, this session is language independent. Okay, this session is in such a way that it is kind of a language independent. There is no language dependency. So anyone who is familiar with C++, Python, Java, no matter what the language is, you can take this session. Okay, so now let's see what a problem introduction is. So majority of problems are solvable, right, by computers. There are some unsolvable problems like NP or NP hard, NP problems. So those we are not talking about them right now. Okay, that is a different scenario wherein we those problems are which are not solved, which cannot be solved in a polynomial time. So right now we are not focusing on them. Okay. Yeah, sure, Aditya. I will give you a quick intro of algorithms as well. How to write an algorithm. Okay, cool. So now these are the first things when you see a problem. Let's suppose I told you to write a problem, to write a solution, or write a program of printing all the Fibonacci numbers. Okay, Fibonacci series is there, or write the factorial of the program, simple programs. Okay, so what are the things that you should first analyze? Okay, so these are the things that you should analyze in a problem. First, you should do the analysis. What is analysis? I will talk about it. Then what is the number and the type of inputs? What is the input type? Is it a float? Is it an int? Is it a char? It is a string? Anything, right? Depending upon your language. Okay, so you just look for these two steps first. Then what is the output type? That are you supposed to return a series? Are you supposed to return an integer series? Are you supposed to return a float? Are you supposed to return a string? Very important. Okay, so because most of the problems that you solve either in competitive programming or in real life, all right, you should know what is the output, what should be the form of your output, right? I have only 2 certificates from. No problem, Jeevan. You can have as many certificates as you can. Okay, so it is not something that you should only have 2 certificates or 3. You can have as many certificates as you want. Okay, and you can start from start from Java programming or C++ is there. Everything is there. Okay, and all of those courses are absolutely free. Okay, so now, once your output is clear, your input is there, your output is there. Now the constraints. What are the constraints? That means what are the conditions? So let's suppose the condition is that your number. Most of the problems that you might be right now, most of you might be also interested in competitive programming, right? There you see a constraint, like let's suppose that n cannot a simple constraint that n is always greater than 0. This is a constraint, right? Your n cannot. So accordingly you modify your program. So if you have clarity on these things, then you can accordingly remove some let's suppose if this is not the condition, right? Let's suppose you are trying to find out okay Jeevan, okay Jeevan, anywhere you feel that you're not able to understand, please write it in the chat. Okay, I will repeat as many times as you want. Okay, so don't worry about it. So let's suppose if I told you to find a factorial of a number. Now if I don't give you this constraint, that means you have to take care of the conditions where the number is negative, right? Okay, where the number is negative, right? So if the number is negative, let's suppose, then you have to return some value, right? Let's suppose if n is less than or equal to 0, return let's suppose return a string, right? By returning a string, factorial not possible, something like that, right? So you have to take care of those conditions as well, right? So one thing is analysis, constraints, number of input types, constraint is there, analysis, and then the flowchart will come. Then once you have clarity over these 3 things, we'll talk about them, over these 4 things, we'll talk about them in more detail. Then we will write a flowchart of that particular problem, and then the pseudocode, and then the algorithm. Okay, now let's see what is the analysis. So let's suppose this is your problem statement. Okay, I have taken a simple problem of a modified Armstrong number, right? This is a modified Armstrong number, and now what does it say? Okay, it says that a number NUM, that this is the number, is considered to be a modified Armstrong number if it is equal to the sum of digits raised to the power, right, to the total number of digits in the number, and it does not end with 0. So you see over here, it does not end with 0. It does not end with 0. Let's forget about this part right now, and let me then take this part into consideration when I'm talking about certain things. Let's suppose now let's try to analyze this problem. So this is the analysis phase, right? So you have this problem over here. Okay, this is the problem, and now it is saying that you have been given a number. NUM, right? It can be anything, right? It can be, let's suppose this is a number, S, anything, string, okay? So now it's saying that you have been given this number. You can go through Cisco, okay? Free, okay. Okay, guys, let's focus on the session right now, okay? So if you have anything else to discuss, maybe you can discuss it at the end, okay? So don't worry about it. So now let's try to analyze this problem. So you see over here, we have this number that is 153 given to us. And we want to find out if this number is an Armstrong number or not. But it is saying that the problem statement is saying that it's a modified Armstrong number. Most of the cases, right, whenever you solve a problem, this thing will not be given to you. This is just a hint for you guys. In most of the cases, this will not be given to you that this is a modified Armstrong number. It will be given to you directly in the form of this, right? So this thing is just for the sake of simplicity, okay? Let's forget about this, okay? Okay. Can I learn C? Yes, Raghav, you can learn C. C is the mother of all programming languages. You should start with C if you don't know anything about programming, anything, right? So, right, you should focus on C. You should start learning C. Okay, cool. So now, let's suppose there is this number, and you want to find out if this number is an Armstrong number or not. So what it is saying that how many digits are there? Quickly, guys, how many digits are in this 153? Write it in the chat quickly, guys. How many digits are there in this number? Quickly, guys. If you want to write anything on the chat, give me this answer quickly, so that I can see that is this logic or multiple. Probit, can you just rephrase what you are trying to say? Okay, 3. Yes, absolutely. Now there are 3 digits. Now what the problem statement is stating that these number of digits should be raised to the power of each digit, right? So let's suppose there is a one digit is 1, then there is 5, and then there is 3. These are the 3 digits, and the number of digits are 3. So you raise to the power this number, you raise to the power this number, you raise to that number to this number. Okay, so that means 1 raised power 3, 5 raised power 3, 3 raised power 3. Okay, is this thing clear? Now when you add them up, right, so 1 raised power 3 is 1, 5 raised power 3 is 125, 3 raised power 3 is 9, 3 raised power 3 is 27, right? When you add them up, you will get a number which is 153. Now if this number, the number that you have originally, that is this num, and this number is equal, right, these two numbers are equal, then this is known as your Armstrong number. Okay, Nutan, is this clear? What is an Armstrong number, right? So this is your Armstrong number. Now you might be saying, sir, okay, if the digits are 4, let's suppose you have 1, 5, 3, 4, right? Now there are total number of digits are there 4. So 1 raised power 4 plus 5 raised power 4 plus 3 raised power 4 plus 4 raised power 4. When you add them up, if it is equal to this number, then it is a logic of any programmatic problems are multiple. Yes, Probit. There are multiple logics, right? So let's focus on the end, or you can say the result of that, right? So there are multiple logics, yes, but these things will remain the same, right? So if you are able to jot down your problem into these steps, right? First find the flowchart, then write the pseudocode, then write the algorithm, then it makes it easy for you to get to that the most efficient algorithm, right? So now your task is to check if the given number is Armstrong or not. Okay, so this is your problem statement. Okay, now let's try to analyze. Let's see the analysis phase. What is the analysis phase? A number is given to us, correct? Yes, 153 was given to us. Need to check if the number is Armstrong or not. That is the result that we want to get ultimately, right? Now the questions that can be asked based on this question. So now this is how you solve, how you use the logic of one program into different programs. This is how you build your repository kind of a thing in your or you can say that if you have written it somewhere, then this is how you how you try to let's suppose strike down with a one stone you're striking down 3 different birds, right, or parrots or anything, right? So this is how you do that. right? So you have this particular problem over here. These are the questions that can be asked based on this problem. But that means you will be using this concept that is over here, this modified Armstrong number. This same concept will be used in these three different problems. Okay, this is the analysis phase. You will get, as soon as you solve problems, you will get more and more idea what I'm talking about. Okay, so I can ask for a range of numbers, right? So let's suppose 153 is there. I will say give me all the numbers which are Armstrong number from 0 to 153. Okay, this is one question that can be asked. Ask the type of output expected, right? What is the type of output that can be expected? So let's suppose the type is, right now I'm saying yes or no, either true or false, right? So this can be one question that you might be thinking, right? What should be the type? Am I supposed to say a true, false, that this number is an Armstrong number? Am I supposed to say true or false? These are the questions, right? And then the total number of digits is not given. Is it given or not? Let's suppose this is 153. If I'm giving you that the number of digits is 3, that means your problem, sir, start my career in coding. Okay, yeah, this is the first step, right? Sujit, this is the first step. If you want me to repeat, I will repeat again. So now, if this thing is given to you, right, the total number of digits of any number, right? So let's suppose you have a number 1534 and it is given to you that the number of digits are 4. Does it solve your problem? Or I can say that, does it solve 30 to 40% of your problem? Yes or no? Quickly, if it is given to you. So these are the questions that you can ask, right? So you should ask these questions. What should be the range of this number? What should be the range of this number meaning that am I supposed to get a number which is from 0 to 153 only? Am I supposed to get the number which is less than 1000, right? Or I can say that it should be greater than or equal to n, and it should be greater than 0 and it should be less than, let's suppose, 1000. You cannot exceed this. So these can be the questions, right? Yes, it solves your problem 30 to 40%. Okay, so this is very important, guys, asking the right questions, right? So this is the analysis phase. This is your something which you analyze, and then if you are in an interview or any obviously now if you are facing a face-to-face interview, you can ask these questions, right? But when you are in a coding round, let's suppose there is no face-to-face interview kind of a thing, then you need to analyze this problem, and then based on the question, everything will be given to you. Now let's come to the next phase, which is the input and output. So obviously your input type is integer, which was self-explanatory, right? 153 was there and the input was only 1. There was one input given to you, that is the number 153, right? Then the next output is that you should assume that, okay, you are assuming that this is the boolean. You are either supposed to get either true or false, okay? Because now you might be saying, sir, how would we assume this thing, right? Is this the question that you might be asking? Because in the question it was not clear, right? It was not clear. It was not given to you that the number that the output should. It is saying the last step is that only it's saying that the number is an Armstrong number. Check if the number is Armstrong or not. This is the thing. Now, in every program or in any programming competitions or anything, right, there will be always the test cases that will be given to you, right? If this is the output, right, 153 is the Armstrong number, then there will be an explanation given to you, then there will be the result will be either 1 or 0, right, or true or false. So you can easily assume, okay, you can easily predict from that test cases, and there won't be given only one test case, there will be two test cases minimum, right? So that it is easy for you to check whether the output is in the form of boolean, or is it in the form of true or false, or is it in the form of integer 1 and 0, okay? And now, but it is obvious that you can also find out the number of inputs, okay? So let's suppose I'm saying that in the test cases the output was like this: 153 true, or 153 1. So here the output is not 1. There are number of outputs are 2. So one is an integer, another is a boolean, integer. So depending upon the test cases, you can easily predict the output. Okay, is this thing clear, guys? Am I making sense to you guys? Are these two parts clear, right? First was the analysis phase. The next was the number of inputs and the type of that input. Okay, and similarly the output and its type. Okay, is this thing clear, guys? Do you want me to repeat these 3 steps? This is very important, guys, to solve any problem, this is the first question that should come in your mind. What is the analysis phase? What is the analysis that I'm going to do? What is the input that is given to me? Am I supposed to find the Armstrong number? What are the questions that you should ask or you should analyze? Or let's suppose, what is the range of the number? How big a number, how big this integer number can be? Okay, what should be the type that is expected? How many, if the total number of digits is given to us, right? This is all your analysis. Then input and output, right? What should be the input? What is the input and what should be the output, right? Make sense? Then finally, the constraints. Now, you might be thinking, sir, what is this constraint, right? So in the question, when I told you guys, forget about this part, it does not end with 0. Okay, sir, can you repeat? Okay, so okay, I will repeat. Okay, so quickly guys, how many guys understood each and everything? Just give me a quick information in the chat. Okay, then I will quickly reiterate what I said. Quickly guys, yes, no, maybe. So the first step that the first step was the problem introduction, problem statement, right? This is the problem that was given to you, right? And in this problem, when I read it, right, when I analyzed this problem, certain things were clear, but certain things were not clear, like the output, the range, right? So now the first step is reading out your problem, right? You have read it, your problem, and this is your problem, right? You have given a number, and in that number, you are supposed to find if that number is Armstrong or not, right? Okay, Subramaniam, I will repeat. Okay, no problem. Okay, great. So now, what I am saying, that you have been given this number and you want to find out whether this number is an Armstrong number or not. Now, what is an Armstrong number? If you have been given this number, how many digits are there? 3. Now, when you raise this 3 to these 3 digits, right? Let's suppose 1 raised power 3, 5 raised power 3, 3 raised power 3. That is what is saying, right? An Armstrong number is equal to the sum of digits, right? Sum of these digits, right? To the power of total number of digits in a number. To the power, that is the total number of digits in this number. That is 3, right? So 1 raised power 3 is 1, 5 raised power 3 is 125, and sir, what should I study? So Jeevan, you should start learning the basic concepts of ethical hacking. The courses are already available on our Great Learning Academy. You can go through it and register yourself. Then the next steps, while going through that course, it will be clear to you what should be the next thing that you should do. Okay, so now 125 and 3 raised power 3 is 27, done. And when you add them up, it is 153. It is the same number that we had earlier. So when you have this scenario that this is your Armstrong number, right? And then you want to check if this number, that is this number, is Armstrong or not, right? This is the problem. Clear? The next thing is that now the steps that we have to follow. The first step was the analysis phase. In the analysis phase, we have been given, you analyze that, okay, I have been given this number 153. I have to check whether this is Armstrong number or not. Then the questions that you might be thinking, that what is going to be the range of this 153? Is it going to be, can it be 0, or can it be something which is, let's suppose I'm saying this number as NUM, right? I'm saying, is number greater than or equal to 0, right? Is this number, can this number be 0 or equal to 0? Can this number be less than or equal to 1000? So these are the questions that you should ask, or these are things that will be given there. But yeah, while reading the problem statement, this should be clear. Okay, then what is the type of output expected? Is it going to return me an integer number? Should I return an integer value? Should I return a Boolean value? So these questions are not clear yet, right? And then what if the total number of digits is given or not, right? So the total number of digits in this number is 3. Is this 3 given to me or not? Is there anything that is okay, I might say that, okay, this 3 is given to me. So let's suppose if it is not given, then you have to calculate it. Now if it is given, then it reduces your problem to maybe 30 to 40% of your problem is solved, because this is the main scenario. You have to calculate the number of digits. Okay, so this is all your analysis phase. Okay, now the next thing is input and output. What should be the input and output? And it will be clear with the help of test cases that is given to you. So let's suppose you have been given a test case 153. There's an explanation that 1 raised power 3, 5 raised power 3, 3 raised power 3 is 153. This is your Armstrong number. and plus there will be an output given to you that, let's suppose, true. Then you will be able to find out, you will be able to deduce this thing. Obviously input will be clear, right? But this output you will be able to deduce with the help of test cases. Okay, so obviously now when you have this explanation over here, you will get a little bit hang of the problem, maybe understand the problem in a much better way. Then the output, obviously you can then say that, okay, unless and until it is not given, but that won't be the scenario, right? Then you can easily ask your interviewer. Okay, mostly in face-to-face interviews there might be the case that these things are not given to you, then you can easily ask. But when you are facing what is a boolean is a data type. That means you can either have your output, the value that the domain of this boolean is either true or false. Okay, the output, okay, just like 0 and 1. Okay, yeah, yes Karthik, correct, right? So boolean will be the output, and the number of output obviously is 1. There will be only one output. Let's suppose if there is like this 153 true, then you can say that the number of output is 2. Okay, so this is all about input and output. Okay, correct Zakaria, yeah. Okay, now the constraints, the most important thing which I told you earlier, that what is this? It does not end with 0. That means your number, any number, must not end, because this is the constraint, right? This is the constraint given to you. Obviously this is the scenario where we can assume that in this question it is given to you, but maybe in some other questions this won't be given to you. Then you have to deduce, then you have to keep this scenario into consideration as well. Now the constraint is that your number, let's suppose you have 100, you cannot have this number because this is ending with 0. Okay, conditions for Armstrong number, right? What are the conditions for Armstrong number? That where you need to find out first that the number which is given to you should be equal to the number of digits when you calculate like this, right? And then you have 3 add the 3. So this is the condition for equality, right? Condition for checking if the number is Armstrong or not. That is 1 plus 125 plus 27. Okay, so this is the condition, right? These are the condition that only when you have this scenario, then you can say that this is an Armstrong number. Then number of digits is not given, so you need to find the number of digits as well. So 153, you need to find the number of digits as well. How do you find a number of digits? Quickly guys, now I'm asking you this question, so this constraint thing is also clear. Then we will move on to the flowchart thing. Before that, can you guys quickly tell me, if you have been given this number 153, how do you calculate the number of digits in this? Quickly guys, do you have any idea? Yes, no, in the chat. Quickly guys, it's very easy. Quickly guys, how do you? Okay, quickly. Yes, correct Probit. Yes, you do a modulus operation. Modulus means that you will be finding the remainder. So let's suppose if I am doing a modulus operator of this number, what will be the remainder? 3. Then I will say that, let's suppose this n is equal to 153. Now what I will say, that first step is that I will say 1, let's suppose this is r, and I will say n mod 3, right? Or let me just put it in a better way. You will have one counter which is starting from 0. That means it was used to count the number of digits, right? Then the next thing is that you will have this number, you will check while if your number is greater than 0, right? Because you will stop then, right? And your n is equal to, let's suppose in this case it is 153. Then you will check if your n n is not right now 0, right? It is 153. You will find out the remainder, or you can say that you don't need to find the remainder in this case as well. So you will say that n mod 10, or forget about it, n divided by 10. You reduced your number, right? Now when you are doing this n mod or n divided by 10, you will get what? let's suppose this is your 153 divided by 10, right, and you get 15, you get 150 over here, and the remainder is 3. We are not concerned right now with what the remainder is, right? So we are only concerned of how we can reduce this number. So the new number is 15, so you have reduced it from n to 15, right? And then you check again, and what else you can do, you will increase your counter. That means there is one digit, that is sure. Okay, now C is 1. Again you will check n divided by 10, that means 15 divided by 10, right? And then in this case you will say 1, that means you will have 10, and the remainder is 5. We are not concerned in this case, we are not concerned with what the remainder is. Okay, so then again the count will be 2. Then again we'll check if n is greater than 0. Yes, it is 1 right now. Then we do again 10 divided by 1. In this case you will get 0, and you will get the remainder as 1. Okay, and in this case you will again, now your n is, this time it is 0, right? Right, and then you increment your counter, that is 3, right? And then once this n goes back, it says, is n greater than 0? No, it is not. It will go out of the loop. That means you will have your counter as 3. That means the number of digits is 3, right? Simple. We are not supposed to, some of you might be thinking, sir, why didn't we check out the mod operation? Because right now I don't have that requirement, right? Yeah, I don't have that requirement, right? So I am not concerned about what the remainder is. Let's suppose if I am trying to reverse a number, or maybe write something which is 153, it should be 351, right? I am converting this number, I am converting the number of places. At that time I might require my remainder, but in this case I don't require it. Okay, simple. So now this is how you calculate the number of digits. Let's move on to the next thing. Let's try to write the flow chart now of the same problem. Okay, so a flow chart is nothing but a pictorial representation of steps that you are going to perform in order to find the solution. Okay, it enables you the visualization, how you can visualize your problem. Okay, so what is the role of shapes to solve any programming problems? Just like pattern, problem related to shape of a triangle. So basically that those are your what you have currently any problem. Let's suppose you have to print these, right? Let's suppose you have 1 1 1, then you have 1 2 1, or let me just keep it simple, 1 1 1, and then you have 1 1 1 1 1. You are trying to print out this thing, right? This is one kind of a shape that you are trying to print. This is nothing but in order to check whether you can solve this problem or not. Basically it is called as what, triangle print this pattern, right? So basically you have to use, in these kind of problems, you have to play around with the loops and the number of rows that are there. Let's suppose you have one loop which will take care of the number of rows, then you have another loop which will take care of printing these things, right? 1 1 1 1 1. Then you have another loop which will help you to print these spaces from here, from here, from here, from here. Okay, so these are the three things, right? Simple. So whenever you have these kind of problems, right, whenever you are trying to print the shape, you have to think of in three different ways. One is, how can you print the number of rows? How can you print the spaces? How can you print the numbers that are there? It can be 1 1 1, it can be 1 2 3. Okay, so that is the shortcut for solving those problems, right? So it helps you to build the logic, basically, right? So Jeevan says, is Great Learning free or paid? So right now you are in this session, so obviously this is a free session on YouTube, and the courses that I showed you, right, the free courses, those are all free. So if you are looking for something, the advanced certificate program with IIT or an MCA degree program, that those are paid courses, okay, or paid programs, okay. Now it helps you to visualize the problem, okay, and it shows you the clear flow of data. So how your data flows, right? Data flow. So first you have the input, then you move on to the next step. You store your number in a different number. I'll show you what the flow chart is, and what are the things, what are the shapes that you are going to use in the flow chart, okay. So it helps you to, with the help of arrows, how you are transforming through your program, okay, and it can be used for any non-technical audience. So let's suppose there is someone who is not familiar with programming languages, but this tool, that this flowchart, helps him also, right, he is non-technical person is also able to understand your program better. Okay, and it has a definite start point and an end point. Let me show you what do you mean by these things. Okay, so first let's try to see the shapes that we are going to use. So this is the terminal where you start and end your flowchart. Okay, then you have input or output, any input that you have, right? Let's suppose you have a number which is an input, right, 153. You have an output which is boolean, so all those things will be in this shape, right? And then you have this rectangle over here, processing, where you add, multiply, divide, whatever the processing is, that you will do it over here. Then any decisions, like if n is greater than 0, what you should do, you should stop calculating the number of digits. So any decisions that you make should be in this in this shape, right? And then you have the connectors, right? So let's suppose if this is basically used when, let's suppose you have an on page connector and off page connector. Let's suppose you are at the end of this page and now you have to write your program. So I will use this connector and connect it over here. So just to show that the connectivity of this flow is like this. So you have this, you are at the end, then you started from over here, and then you are starting, that this is the entire flow of this particular program. So just to show the flow, then you have these arrows to show the next step that is there in the program. And then finally you have off page connectors. Let's suppose you are on a notebook and your program has finished and you don't have any space left. You have used these on page connectors, then you move on to an off page connector. You write this first step of your flowchart and then you start again. Okay, so these are all the connectors, how you show the flow. Okay, nothing special about these. Okay, sir, which app can be used for practicing the flowchart? Jeevan, you need to find that out. Okay, cool. Let me just clear it out and let me just show you how you write the flowchart of this modified Armstrong number. So as I told you earlier, so guys, if you are not able to understand any step, please let me know in the chat. Okay, so you have to start it from here. Okay, excuse me. Yeah, so you start with this, you write the start, that is your first, that is the terminal, and I will end with the same terminal. Okay, so you start it, and then what is the input, right? I told you the arrow things, right? So to show the flow, right? So now then you have your inputs in this kind of a thing, right? You write input n, your number, right? And then you will check the condition. If this number is if you do a mod of this and you get a 0, that means the last digit is 0, which is the constraint that I was talking about. As I told you earlier, your last digit cannot be 0. Was that the constraint? Yes, it was. Let me go back and show you this constraint. It does not end with 0. So first I will check this, because then there is no point of finding out the Armstrong number, because that is the constraint. So I will check if this num, that is this number, mod 10 is equal to 0. Correct? Is this thing clear? If this is equal to 0, then obviously I'm going to stop, right? And I will just put a no over here, and then I'll put, if it is equal to 0, then I will stop my scenario. Yes, it is. I will stop my scenario. If it is not, then I will continue. Okay, then I will have one more input, that is my count, which is 0, which helps me to calculate the number of digits. Okay, then I don't want to change this number. Why? Because in the end I will be checking if n is equal to some number, the calculated number, right? So I can use a temporary variable to store this number and then play around with it, so that in the end I can check that the number is equal to this thing, right? So that is why I'll be using one more variable, which is temporary variable, to store this number, which is n. Okay, is this thing clear? Now once I am done with this thing, now I will be playing around with this temp. Okay, so I will use one connector over here. I will use that connector, the on page connector. Okay, please, is it UML? It is not a UML diagram. It is basically your flowchart. Okay, so how the program is, how basically with the help of this I will show you the what is the correlation between a flowchart, then moving to an pseudocode, then moving to an algorithm. The same thing will be applied, okay? The same thing will be applied throughout your program, okay? So now once you have this thing, okay, now you have this temp, and now what I will do, I will just calculate the number of digits, okay? I will say if temp is greater than 0, that I told you earlier, right? Then if it is, I will say yes, I will do C++, that is count plus plus, and then what I will do, I will say temp equal to temp divided by 10, simple. Then this is a while loop, so I will bring him again over here to go through this loop kind of a structure, right? If it is not greater than equal, or let me just rewrite this thing again. Yeah, so if it is not, then what I will do, I will say no, and then I will again check. I will again increment, I will again use this temporary pointer equal to, setting it again to n, which is my number, okay? So which language used for this program? This is language independent, guys, okay? I will repeat it, I will repeat each and everything again. So just focus on this flowchart, because this is where the crux of this problem lies, okay? Then I have this sum, which is used to calculate the number of digits, that is 1 raised power 3 plus 5 raised power 3 plus 3 raised power 3, right? So I will have this sum over here. Then I will use again the connector. My connector goes here, okay? Let me just write it in a different color. Yeah. Now what I will say, now I will check. I will say if my sum is equal, now obviously now my sum is equal to 0, I will check if temp is greater than 0. Yes, it is, right? If temp is greater than 0. If it is not, I will stop. If it is greater than 0, then I will be adding those things up. How? I will first pick the first number, or the last number. Now, how can I pick that? Let's suppose I have this x variable over here. I have defined it somewhere. I have this x over here. I will say temp mod 10. What does it give me? It will give me this last digit, which is 3. I will say okay, and then I will update my temp, which is temp equal to temp divided by 10. I will update my temp as well, right? Done with these two steps. Then the next step is sum, which is this sum equal to, or I can say the sum equal to sum plus power of, that is the power function that I am using over here. You can use a multiplication of those numbers, right? So since I am trying to make it dynamic, right? So that is why I am using a power. Then this x, which is 3, raised to power the count, which is this number, which I have already calculated the number of digits. So you have 3, you are raising it to the power of 3, right? Now this is the step that you are doing over here, and then you will be performing this step again and again, unless your temp is not equal to 0, okay? Done. So now what will be the output? It will be something like this: 3 raised power 3, which is 27, plus, now the next digit is 5, that which will be calculated with the help of this x, and x raised power 3, which is 125, it will be added to 27, so which will be around what, 152. Then the last number which is there, 1. Still our temp will be equal to 1, not greater than 0. It will be greater than 0, right? So now in the next step it will be 152 plus 1, which is 153. Then it will check, is the temp greater than 0? No, it is not, right? And then finally it will go from this no, and the last step is this, that you will be checking if your sum is equal to n. That is why I was storing this in a temp. Always I was storing it in a temp, right? So once I am storing in this temp, so that is how I calculated if this is equal to. If I am saying no, then I will print false, right, the output. If it is, I will print out true, and then finally I will end my program, okay? In this case as well, and in this case as well, right? The last thing that was there in this case as well, okay? I hope you understood this. So let me just quickly reiterate through it, a quick revision of it. I know this is quite difficult to understand, okay? So let me just erase these things which are unnecessary. Okay, cool. So now let me just iterate through it, okay, quickly. So you have the start button, okay? You have the start button, you started it and you ended it over here, okay? This is the end, okay? Now what else? You have the input number, which is n. You checked if that last number is 0 or not. If it results yes, then you will stop. You will stop it, okay? You don't go ahead with the program, okay? You have the number, let's suppose 153. So the last digit is not 0. Now you have this counter which will help you to calculate the number of digits, okay? You stored it in a temporary variable so that you can use this n at the end to check whether the numbers are equal or not. So that is the whole reason. For else you have to use some variable and then again update this n to, because we are manipulating this n, right? We don't want to manipulate this n, that is why we are using a temporary variable so that manipulation can be done on that temp, okay? Then I calculated in this thing, what I did, I calculated the number of digits. Done. The number of digits that I was able to find was 3, because that I told you earlier also, right? I am dividing this number by 10 and I am doing C++, that means calculating the number of digits. Done. Again I updated this n to temp, because again I will be manipulating this temp itself, okay? I have this sum which is over here, which is used to calculate the number of digits. Which is used to calculate the sum, that is the overall sum. So now after these two things, what do we have? I have the number of digits, that is 3. I have sum which is equal to 0. I have temp which is equal to n, and I have also find out that the last digit is not 0. Only then I can proceed, obviously, which is this step, the first step, right? Done. Then what I am doing, I am one by one, that 153, I am dividing it into digits. So I am first picking this 3 and I am raising it to the power of this 3, which I have already calculated, right? So that thing is done over here and over here. I picked up the last digit, that is 3. I reduced the number of bits that are there. That means earlier it was 153, now it is 15. Then I calculated the power and I added it to sum. So sum is equivalent to 3 raised power 3. Okay, so sum is 27 right now. I did it again. Now this time around I added 27 plus 5 raised power 3, which is 125. The total will be 152. And this time my number will be now 1. Finally I have this 153. Now temp is equal to 0. And now once my temp is equal to 0, I will go into the no section. I will check, is this sum, which is 153, equal to my number, which was 153? Yes, it is. If this is yes, I will say true and I will end it. If it is not, I will say no, I will end it. Okay, so this is your flowchart. I know it is difficult. You can obviously you have these things on your YouTube channel. You can revisit this again and again as many times as you want. Okay, so if you want, you can click a picture of it as well. Okay, just to help you think, understand these concepts more in detail. Okay, so this is very important, guys. Any program, if you are if you are new to programming, right, these things you should know. Okay, so let me just remove unnecessary things so that you can, obviously you have these things on your on our YouTube channel if you have subscribed to our channel. So these things will be already there. So if you haven't subscribed, make sure you subscribe, and also you click a picture of it so that it is easier for you to remember these things what I have done. And right, okay, this is yes, this is end, right, perfect. So this is your true over here and this is your false. Okay, so let me just write it again. This is your true, this is your false. Okay, done. All right, so now let's move on to the next, which is pseudocode. Now this is the same thing, the step-by-step approach, but written in an English language. So earlier it was in the form of pictures. Now what I'm doing, I'm writing it in the form of English, which is easily understood by a layman, and no programming construct is followed in it. That means we won't be using those programming constructs like var keyword in type or system.out.println in Java or printf or C in cout. We won't be using those programming construct. It is a simple transformation of flowchart into your simple statements. Okay, and whenever you're documenting, this is very important, pseudocode. Now let me just show you. It will be easier for you to understand. You have an input number. You check the last digit is the last digit of the number. If it is 0, you return a false, right? This is the first step that we did, correct? Then we counted the total number of digits in the number, that was 3, with the help of that loop that we have, with the help of this loop, right? We calculated the number of digits. This is your second step. This is your third step, right? First, second, third step, right? Now, the third, after fourth step, what we did, we take each digit, that is 153, we took this digit and raised it to the power of the digits that we calculated, that is 3. Add them up in the sum variable, right? That is what we did. We have sum equal to 27, right? Let me just write it again. We have sum equal to 27, right? That is what we did. And we performed these operations again and again and checked whether the number is equal to, we perform this operation unless and until it is greater than 0, right? Unless 153 is greater than 0. This was the fourth step, right? And then the fifth step was we checked whether this sum is equal to the number that we had, right? This is the simplest pseudocode. Obviously, you can make it as precise as possible, but yeah, this will work, right? For now, right? So this is your pseudocode. Now, what is an algorithm? Now here we will be close to actual programming, right? What is the actual programming? How you use your programming construct? So some of the programming constructs will be followed, like I will be using while condition, if conditions, right? And obviously this algorithm is again programming independent, right? There is no programming language followed, but yeah, it will help you analyze this time and space complexity of your problem. And it will help you to optimize it further. So let's suppose you want to find the most efficient algorithm. This will help you, obviously. Okay. So now let's see what is the Armstrong number and how do you write the algorithm. So you check, you have the input number, your first step. You checked whether the last digit is 0 or not. If yes, return false. Finish your program. Done your program. You are done with your program. Then you have this temporary variable. You use that temporary variable to store num. Done. You have this counter which will help you find the number of digits. So this is finding your digits, right? While temp is greater than 0, count plus plus, temp equal to temp divided by 10. You do it again and again and again. You have your C equal to 3 in case of 153, right? You have your number of digits. Done. You updated your num because you will be again manipulating the number and we don't want to manipulate this number. Okay. And that is why we are using this temp. We have sum equal to 0. Clear? Is this thing clear? Then the final step is that while our temp is greater than 0, we calculated, we have that temp, right? It should not be here. It should be, there should be one more. Okay, I have used over here. Okay, so yeah, so what I'm doing over here, so I can either use this like this, temp equal to, or I can use that one more variable over here. So just not to use that one more variable, I have directly written that over here. Or you can use x equal to temp mod 10 and then you will use x over here. So just not to use that extra variable, I have directly written it over here. Okay. So sum equal to sum plus, that is math.pow, that is calculating the power of a number. So this will help you calculate 153 is your number. So the last digit will be picked, that is 3. Then the count you have already. That means you will give these two arguments to the math.power function. It will calculate 3 raised to power 3, which is 27, and it will be added to sum. Sum earlier was 0. Now 0 plus 27 is 27 will be the value of sum. Then you reduced your number to 15 because of this step, right? Done. Then again you check if temp is greater than 0. Yes, no, it is not. It is obviously it is greater than 0. It is 15, right? Again you calculated the value. So this time you will do 27 plus 5 raised to power 3, which is 152. You check, you have that sum. You reduce your number to 1. Is 1 greater than 0? Yes, it is. You calculate the power, that is 1 raised to power 3, which is again 1. 152 plus 1 is 153. You divided the number by 10, right? And now this time around your number is 0. Is this greater than 0? No, it is not. You stopped. Now your sum has 153. You check if your sum is equal to num. Yes, it is. You return true. Else you will return false. That is the end of your program. Okay. This is the end of your session, guys. So thank you so much and let me know in the chat if everything was clear. So basic steps that we performed, right? Starting from flowchart, same thing that we used pictures to represent a problem. Same thing was jotted down in the form of English sentences. Let me just write it again. So same thing, earlier it was in the form of pictures, right? Then we jotted down it in the form of English language. We had that pseudocode, and then a little bit of programming constructs were used, right? Like while, if. So some programming constructs, but again programming independent or language independent, you can say language independent, right? We had that algorithm over here. Now once you know the algorithm, you can implement this thing in C, C++, Java, Python, or JavaScript. Okay, quickly guys, if you want me to repeat anything, or is this thing clear to you guys? The flowchart was the most difficult one. Apart from that, everything should be clear, right? Right guys, so quickly give me a confirmation in the chat if everything is clear. Then we can wrap up this session, and I will see you in the next session. And if you have any feedback or anything, you can put them in the chat. And also, if you haven't subscribed to our channel, make sure you subscribe to our channel. And again, if you want to learn any programming language or data structures or algorithms, that is already present on our YouTube channel. Okay. And not only that, it is also present on our Great Learning Academy. Okay, you can check that as well. All right. So thank you so much, guys. All right, Probit. Thank you guys. Thank you so much.